Okay, so here we are with Unit 7. We're going to do graphs of exponential functions. So with an exponential function, there are two types of exponential functions that you're going to need to know, and that would be growth or decay. So growth is based on when you have, so basically the exponential function looks like this, a times b to the x. So this b value right here, that's the base of your exponents. A is just a multiplier, right? So it's just like a dilation, a stretch or a shrink. But b, the base of that exponent, if that b value is bigger than 1, then you're going to have a situation that's called a growth. If b is less than 1, but it still has to be bigger than 0, then that's going to be a decay. Because imagine a problem like this. Let's say we have an exponential function of y equals 2 to the x, like kind of like a basic one. If I put a number like 0 in here, 2 to the 0 is 1. And then if I put a 1, 2 to the 1 is 2. If I put a 2, right, that would mean it's 2 times 2, so that would be 4. And if I put a 3, that would be 2 times 2 times 2. And so basically what we can see happening here is everything's multiplying by 2. So everything's doubling, so everything's growing, right? So that's why that's called a growth. If I put a negative 1, well, 2 to the negative 1 means it's 1 over 2. And then put a negative 2, that would be 1 over 4. And 2 to the negative 3, that'd be 1 over 2 to the third, which would be 1/8. So what ends up happening on this graph is this. When your numbers are negative, you get really small answers, and they start to grow. 0 is 1, 1 is 2, 2 is 4. I don't have room for 3, but it's about up here. But no matter what I put, no matter what negative number, how small the negative number I put, it will never be 0. These over here on the right keep rising. And on the left, it comes down super small, but never 0 and never negative. So what ends up happening is you have a horizontal asymptote, because no number placed here would make you have a negative answer, nor would it ever make it 0. Okay? So you have a horizontal asymptote of y equals 0. And that can move, based on if you move the graph up or down, left or right. So this is the exponential growth. Now you'll see a decay later on, but if you had a decay, and you can see here, it's starting from the left is how we read a graph. It goes and it grows, right? If it's a decay, it's going to start high and it's going to come down through here and decay. That would be an exponential decay. It still goes through the point 0, 1. Still has an asymptote of y equals 0, but that's a decay. And that's if your base number right here is a number less than 1 but bigger than 0. Okay? All right, so let's talk about our domain. This graph goes left and right forever, so my domain is negative infinity to infinity. I can plug anything I want in for my exponent. Positive, negative, zeros, decimals, fractions, doesn't matter. My range, though, will only ever be anything positive, so it'll be from 0 to infinity. It doesn't touch 0. It doesn't go negative. And of course, this is for this basic graph where it hasn't been moved up or down or left or right. Mins and maxes doesn't really have any because it's like a smooth curve there, always increasing in this case. So increasing from negative infinity to infinity. So if you look at this graph, it starts low and then rises. Now when you have a decay, that would be decreasing, right? But for now, this doesn't have any decreasing or constant areas. The end behavior, as I go to the left, the graph kind of bottoms off and approaches 0. And as I go to the right, it goes up to infinity. Y-intercept is 0, 1. That's kind of like, in a way, like the corner of the graph, but, kind of like a centerpiece. And you can imagine if you're moving right or left, up or down, that's the thing that kind of moves around. X-intercept, there isn't one, because I haven't moved the graph at all. Okay, so if you want to move this graph left or right, just like we have in the past, you're going to have to, let's just take 2 to the x again. You're going to have to put a number with the x. So let's say we go -3. So that would move the graph to the right 3. So this is the point that I can kind of like move to the right 3. So move it to the right 1, 2, 3, and it becomes here. Since I'm moving left or right, the horizontal asymptote that was here, it's not going to move at all, right? It doesn't have to, if you move something to the right, if you move this over to the right, it doesn't change. It's still y equals 0. All right, so let me erase that. Oops, 3. I still have my horizontal asymptote. And the graph just kind of sneaks over up through there now. All right, so let's do another one. I should have done that in blue. All right, if I want to move my graph and say, let's do like 2 to the x plus 1. So that's going to move everything left 1. So at this point moves here. The asymptote is still at 0, so now it's going to be looking like this. Okay? And of course, if you wanted to find your y-intercept, you can always plug in 0 for x, so that would be 0. And 2 to the 0 is 1. 1 plus 1 is 2. So I should have drawn this. Let me fix this up a little bit. 0, 2. So I should have crossed right here and gone across there. Okay. All right. If you want to move it up or down, let's do a decay function, like a 1/2. How about 1/2 to the x, and let's move it minus 3. Move it down 3. So this affects the asymptote. So the graph, was going to be blocked here, but now everything's getting moved down, so that asymptote is going to move down 3. And basically my point that's right here is also going to move down 3. So down 1, 2, 3, and it's right here. Okay, so let's see. Right there. And there is a way to find the x-intercept, but we don't really know that yet. I mean, you don't know how to do that just yet. So just leave it for now. Hey, get down. Rocky, get down. Hey. Rocky, get down. Sorry, let me put my dogs inside because they're bad. Come on, get inside. All right, so where were we? Oops, and I've drawn that last one incorrectly. I just realized that now. It was a decay function, right? So it's going to be traveling down. Okay, and so, if you do a plus, it moves it up instead. A reflection over the x-axis. So when you reflect over the x-axis, you're going to go ahead and flip over. So that would be a graph like, y equals negative, and like, let's say 2 to the x. So normally I would say, okay, it's going to grow, but it has to flip over. So that's going to turn into this. So it's going to turn into this. Now, one thing you can also do with these, you can also have a reflection over the y-axis. And when you have a reflection over the y-axis, what you do is your negative sign is going to be with the x. And so in that case, normally this is a growth function, y equals 2 to the x, but reflecting it over the y-axis means it flips over this way. So actually, it ends up kind of looking like a decay. But it was a reflection. Okay, and a vertical dilation, a stretch, and a vertical dilation of a shrink. So if we want a vertical dilation, a stretch, let's do like a 1/3 as my base to the x, and let's put a stretch to put like a 2 here. So all that's going to do when you have a decay, it's just going to make it like steeper, faster. So notice that if I put in 0 right here, if I plug in 0, I still get 1/3 to the 0, which is 1, and 1 times 2 is 2. So I have this y-intercept. And so notice what used to be 1, but now it's at 2. So everything is just like taller sooner. So it's just going to be a little bit steeper and come through here and then go across. Okay. If you have a shrink, That's because, let's say you have a 1/2 in front, and then you have, let's say, I don't know, 4 to the x, let's say. So if you plug a 0 in here now, and again, the asymptote still over here. And let's see, so if I plug a 0 in here, I get 4 to the 0 is 1. 1 times 1/2 is 1/2. So you notice this thing is lower, right? So everything's just going to be kind of like lower to the ground sooner. Okay? And you can see those on Desmos and whatnot. It's kind of hard to draw them perfectly here. All right, so let's put it all together here and just try and do a couple motions at once. So your first job in these is going to be to decide if it's growth or decay, so you know what kind of base function you're dealing with. And so this right here tells me that this is a growth problem. And it's moved to the left 4 and down 1. So imagine you have this horizontal asymptote. What's going to move it? Well, down 1 is going to move it. So my new horizontal asymptote is y equals -1. So once you have that, then you can kind of take this this point right here that you used to know, and you can move it to the left 1, 2, 3, 4, and down 1. And then there's kind of like your new place where that kind of turning point is. All right, so let's go ahead and draw the asymptote. And let's see, from 0, 1, I'm going to move left 4, down 1, so there it is. And then the rest of it you can get from your calculator or Desmos, but it's growth, so it kind of comes up like that. And we're just looking for a sketch, really. Okay, this next problem is also growth, and it's moving up 2 here. So my new horizontal asymptote is y equals 2. All right, and so this problem has a, what's it called? A stretch in it, right? Like it has a dilation of 3, so it's stretching. So let's do something. Let's go ahead and try and do like a y-intercept, just to help ourselves out and give us a point, because we can't really use this point anymore, and like move it around because it got stretched up. It actually got stretched up to 3 because 1 times 3 is 3. But we'll just find the y-intercept, and that way it'll give us like a place to go through. All right, so if I plug 0 in, 4 to the 0 is 1. 1 times 3 is 3, and 3 plus 2 is 5. So there it goes there. So we know it's going to like come across here and then eventually go up through there. Okay, because it was a growth. Okay, on this last problem here, I have a decay. So my basic problem is looking like this. Okay, it's moved to the right 1, and it has a reflection over the x-axis, right? So it's not moved up or down, so my asymptote is still at 0. So I have to move this thing from this point, and I can just use that point. I can move it right 1, and then I have to reflect it to down here. All right, reflect it over the x-axis. So let me get rid of all this stuff. Okay, and yeah, it was decay, so now it's going to look like this. Okay, so it's basically this thing flipped over. So that's not too awesome, but it's just, again, supposed to be kind of like a sketch. Okay, all right, just to get a general idea. Okay, in these two problems here, I have not done any dilations, so we're basically going to be looking at these graphs here. It looks like that I have an asymptote here of 2, so y equals 2. And to come up with an equation, we're basically not sure. We're just going to treat this as a decay, I guess. We don't really know what exactly the base of it is, but if I kind of look, it's kind of hard to see. Went up 2, and probably this point right here is going to be since there was no dilation, I'm looking for the point that's like 1 unit away, because remember the original graph, this spot is 1 unit away from your horizontal asymptote right here. So it looks like I moved to the right 3 and up 2. So that equation is going to be to the right 3. So I'll just put a base of 2. So x right 3 minus 3 and plus 2. Now again, this thing I'm not sure of. It would take some more inspection to figure that out, but this is just a basic idea. Oh, also, so this is a decay actually, so that's not correct. I'll be putting like a 1/2 there. And then x minus 3 plus 2. But again, it would take, I kind of really don't know what this is. I just know that it's a number between 0 and 1. Right? It would take a little bit more work to figure that out, but we're not super interested in that. All right, so here I have a horizontal asymptote of -4. So y equals -4. So I can tell that this equation right here, we'll figure out the base later, but there's a -4 here. And it looks to me like this thing used to be a growth, but it got flipped over. So let's go ahead and put a negative sign. And a growth, one would just put, we don't really know, but it has to be a number bigger than 1, so it could be like a 2. Okay, and if I look for that point like right there, it's not moved left or right. It has just been moved down 4. So this is pretty good. Okay, so this number we're not sure of. Maybe it's a 2 or 3, some number bigger than 1. And again, we're not gonna like worry about figuring that out, but we're just trying to see like the surrounding things, like the left and the right and the up and the down motions. All right, and